All right, this is a test. This is not a test. This is a lesson called 5.3. And my informal title is It's a Converse of 5.2. So if 5.2 was if P then Q, we're going to be flipping that around to saying most of our theorems today are going to go the opposite way. So instead of ending up with, oh, then the lines are parallel, we're going to be starting off with, if the lines are parallel, then blah, blah, blah. All right, first of all, a rather big deal, but not a big deal. We won't be quoting the parallel postulate rule in your theorem, but this is a foundational theorem. It's much discussed and argued about in the world of geometry. Basically, it centers on the idea of how many parallel lines are there to a given line and a point not on the line. Well, most of us would say there exists exactly one line that's parallel to it. So for example, I give you a line, call it M, and a point A. How many lines can you draw through A that is parallel to M? And a lot of people would say that line is not parallel. This line is not parallel. There is only one line, and it's approximately here. Now, without going into a lot of detail here, if you were to break this rule and say there's two lines, right? There is, those two lines are parallel, then the rules of geometry change, and we actually end up with a different type of geometry. We call it a non-Euclidean geometry. And there are applications for non-Euclidean geometry, including the Earth that we live on is a sphere. And there we have parallel lines which do meet at a point. So there's multiple lines that are parallel to a given line through a point. All right, well, enough of that for now. We're going to go with the simple Euclidean idea that there is exactly one and only one. It's an indirect proof. I'm not going to go through it. If we had class time, I would do it there, but I'm not. All right, our first one, converse of the AIA. If you have parallel lines, then the alternate interior angles are congruent. So there we have our picture of parallel lines, and then we would know that the green ones and the blue ones are congruent to each other, right? By the same token, we have the alternate exteriors. So, for example, that one and that one, right? Likewise, our other pair of exteriors are also congruent. So feel free to quote that. You can quote it either way, converse of AEA or the if parallel, then AEA are congruent. I'm going to keep going here with one more. If parallel, it's the converse of corresponding angles. So again, if you have two parallel lines, and these lines should be marked as parallels, then we would know that the corresponding angles, so like this one and this one, or this one and this one. Okay, so we could also mark this one, and then that one and that one. Okay, all those angles have to be congruent. In these diagrams here, we see lines are parallel, right? We see the mark there. So what other angle do we see as marked as x degrees? Well, that one is also x, this one is also x, and this one is also x. The rest of them are 180 minus x, correct? (180 minus x). So we have that relationship that all the angles, when you have two parallel lines cut by a transversal, they're either parallel or they are supplementary. Okay? So I'm not going to go through that in detail, but there you have it. Moving on down the road, as Kermit says, let's now look at these supplementary ones. We looked at the congruent ones, now the supplementary ones. If parallel lines, then the same side interior. So again, Always look for the parallel lines marking on the diagram. And then we would mark the same side interior. Again, they're not the same, right? So those two angles have to add up to 180. And then likewise, these two here would also add up to 180. Okay? And same side exterior. So again, this time we're on the outside, so that angle there and this angle here have to add up to 180 if, again, the lines are marked as parallel. Finally, there is one that's a little bit different. This is the perpendicular issue, and I like to call it, I'm going to try a new name this trimester, perpendicular to one, then perpendicular to the other. So if you have two parallel lines, yes, notice they're both marked as parallel. And one of the parallels is marked as perpendicular, then the other one would also need to be marked as a perpendicular. All right? So if perpendicular to one parallel line, then it's perpendicular to the other parallel line. And there's one other parallel problem. It says if two lines are parallel to a third line, so for example, M is parallel to N, and M is also, I'm going to mark it going the other way with a double parallel, right? Then we would know that N and P are also parallel. Okay, so we know M is parallel to N, and we know M is parallel to P. Then we can put these two things together and say, well, N would also need to be parallel to P. It's almost like a transversal concept that we've talked about in the past. So, summarizing. If the lines are parallel, then alternate interior angles are congruent. If lines are parallel, then each pair of alternate exterior angles are congruent. Corresponding angles, they're congruent. Now, angles that are interior on the same side or exterior on the same side, they are, as we say, supplementary. So they add up to 180. Pause, make sure you get those rules in your notes cards. It's kind of important. Your math problems will give you diagrams like that, and they'll have you to solve things. In this case, we see that those two angles are alternate interior. We see the parallel markings, so we can say 2x plus 10 has to equal 3x plus 5. Solve, blah, 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 blah. I think we get x equals 5. And then you can go back and plug that in and see that each angle is 20 degrees. Okay? Finally, proofs. So here we're given a diagram. And I think the key for this, yes, is to look for the parallel lines. Where are the parallel lines in the diagram? And we see them there. The next thing I would do is kind of extend those two lines so you can then see a transversal, right? For example, BE is not a transversal because it doesn't go through both lines. So AD is a transversal. And then what you would do is you would look for lines which are, or angles which are like one of those relationships that we've talked about. And here we can see that angle, we'll call it 1, and angle 2 are congruent to each other, right? So this is a classic case of trying to prove two triangles are congruent. And you can see the two triangles. We know that FA and DE, so FA and DE, those pieces out there. And then we know that these little pieces here are congruent. Well, we know that if you add on a piece, right, that's common. Notice this piece here is common to both of them. It's shared. So I think the first thing we can say out of the gates here is that from A to C is congruent to B to D. And that's by that segment addition postulate that we had. In this case, I'm going to say segment theorem because I'm going with congruence. Yeah. All right. Next, I'm going to say the angle. Angle 1. I'm going to sneak a 1 in here. So we know what angle 1 refers to, and then angle 2. Yeah, are congruent. And there we would say, for example, the converse of the alternate interior angle theorem. And number 4, we now have side, angle, side. So I've got a triangle, FAC. Got to be careful how I read that triangle, right? FAC, EDB. These two are congruent by side, angle, side postulate. And so finally I can take now apart. Angle F is congruent to angle E. And that is by CPCTC. Good luck with your homework problems. Thank you for listening to your geometry teacher. Have a pleasant Wednesday or Thursday, whatever.